All right, so here's our lesson on arc length and radian measure. And we already know what an arc is. When we talk about arc length, you can see there's a definition here in your book. Arc length is understood to be the distance along a circular arc measured in linear units. So we're really talking about how long, like if you were to stretch a string, how long of string would you need to cover a certain arc of the circle. And so our book gives us a hint, and it says that we can use proportional reasoning to find that arc length. So when we talk about proportional reasoning, obviously arc length is going to be related to circumference. So we know to find the circumference of a circle, we do pi times diameter, and that would be for the entire circle, which would have 360 degrees. Well, in this example, we are just looking for the arc length. So I'm going to call the arc length x, or I guess for our notes we can call it arc length. And the arc length is going to be related to the degree that they give us. So that's going to be to the degree measure. So if we go ahead and set up that proportion, we can actually solve this problem. And they tell us to solve in terms of pi and rounded to the nearest tenth. So we're looking for exact and an approximate answer. So if I set this up, pi times diameter, that means the exact circumference is going to be 18 pi, right? Diameter is twice the radius over 360 degrees. I'm going to set up a proportion. I do not know the arc length, so I'm going to call it x. And then I do know the degree measure. They're talking about an arc here that's 60 degrees. So now that we have our proportion set up, we can just cross multiply. All right, that's going to give me 360x. X equals, I got 1080 pi. And I want x by itself, so I'm going to divide by 360, which is going to give me that the arc length, x is going to be, let's see, 3 pi. And I want to tell you, when you write the arc length is written really just like the arc, AB, with the arc symbol over it, equals 3 pi. That's our exact answer. Or we can approximate that to be, let's see, to the 10th, that's going to be 9.4. And then this is centimeters because they give us units there. Now, I do just want to make the note to you that arc length, like how long it physically is if you measured it, is written as AB with a little arc symbol over it. If we were talking about the arc measure, though, that would be like the measure of AB with the arc symbol. That is asking for the degree measurement of how many degrees it is. So just pay attention to the notation difference between those two things. All right, so the second part of this lesson is not technically something that you have to learn in geometry this year. However, put a big little star right there in your brain. This is so important to you for Algebra 2 and for pre-cal because you all are going to see radians in all branches of mathematics that you do after this class. So it would be really amiss of me as your teacher not to share that information with you. So you all know that circles are measured in degrees, but really there are two options. You can either measure a circle in degrees, and that is to say that a circle all the way around is going to have 360 degrees in it, or we can measure it in radians. And the measurement for radians assumes that you have a circle, wow, hopefully I can draw a good circle, with a radius of 1, and radians is related to the circumference, right? We're talking about going all the way around the circle. How far would you have gone? So like one way, obviously what we just said in degrees, if you go all the way around the circle, you go 360 degrees. In radians, we think about what will that be if the radius is 1. So if the radius is 1, circumference equals pi times diameter, which means we're going to get a distance of 2 pi. So that is the definition of radian measure, is that a full circle, instead of saying a full circle has 360 degrees, we can say in radian measure it's 2 pi. So let's talk about how to go between those. And really to go between those, you just need to think in proportions. Okay, so let's think about that. like this first question down here, I picked 4 for us to do real quickly. So 180, that's 180 out of 360 degrees total. Well, I know that a total circle has 2 pi in terms of radians. So if I put an x up here and solve that out, and I'm cross multiplying here, I'm going to end up getting 360x equals 360 pi. So I'm not going to use the pi button. I'm going to keep everything in terms of pi. So then x, or the radian measure, is pi. So that would be your final answer. If we do 60, same thing. 60 degrees out of a 360 degree circle total is how many degrees? X out of 2 pi radians total. So if I multiply here, I get 360x equals 120 pi. Divide both sides, and I'm going to end up getting, let's see, 120 pi over 360, which is really pi over 3. All right, and in radians, you leave it looking just like that, like you would just write pi over 3. All right, pi over 4. So now we're going to be going the other direction. So we're just going to still set up a proportion, and this is really bad form to put fractions in fractions, but I'm going to do it anyway. Pi over 4, that's obviously a radian measure, so I'm going to put that out of 2 pi equals some unknown degree out of 360. So we're going to cross multiply there, and pi over 4 times 360 is going to give us 90 pi equals 2 pi times x. Notice those pi's are going to cancel each other. So we've got 90 equals 2x, and if I divide by 2, that means x is going to be 45 degrees. So pi over 4 in radians is the same concept as 45 degrees in degree measures. All right, so we'll do this last one real quick just to make sure you got the hang of it. If you feel like you know it, pause the video and see if you're going to get this one right. 2 pi x over 360. Cross multiply there, we're going to end up getting 60 pi equals 2 pi x. And then if we divide, the pi's cancel, and if we divide by 2, that's going to mean that x equals 30 degrees. All right, so like I said, this will be on your test, even though it won't be on your state test, but this is so helpful for you to know now before you get to trig, the trig section of Algebra 2 and of pre-cal moving forward.